Hello, everybody. Today I'm going to talk about the significance level alpha. The significance level is the probability of rejecting the null hypothesis even when it is true. It's also known as the false positive. Let's go to an example. Let's say if we have 5% as alpha, then the way we interpret this alpha level is that if we repeat the experiment 100 times, we would reject the null hypothesis 5% of the time, even when the null hypothesis is true. So this is the gist of what alpha is. And we'll come back to this statement. But let's first look at this graph below. So in a z-test, we believe the z-score is distributed as a normal distribution centered around 0 with a standard deviation of 1. So it looks like this bell curve around 0. So that means if somehow we can repeat the experiments over and over, we should get z-score that are close to 0. We should often get z-scores that are close to 0, and sometimes we could get z-scores that are far away. The reason is this green area accounts for 95% of the probability, and this two red area accounts for 5% of the probability. So when we get a z-score that are far away from 0, then we decide to reject the null hypothesis. So what is the statistical reasoning behind setting up all this acceptance and rejection region? So let's go to a concrete example. So let's say that we collected some data, and from our sample, the z-score we got is 5. So according to the null hypothesis, it's quite unlikely to get a z-score of 5. So how unlikely? Well, if you look at the PDF, the probability of getting a z-score more than 5 or less than -5, it's 5.73 times 10 to the minus 7. So this is extremely unlikely. It's lower than 1 in a million. As such a low probability of occurring, do we still believe the null hypothesis is true? In other words, the null hypothesis says that the z-score should be centered around 0 with a standard deviation of 1. So it must be really unlucky that we got a z-score of 5, and we are sort of as unlucky as this probability given. So without any other evidence, one statistical reasoning here would be that the null hypothesis is not true. Because if it's true, then it's so unlikely to get this z-score, this estimate. The data is telling us a z-score of 5, and the null hypothesis is saying that this 5 is extremely unlikely. So we choose to believe our data and reject the null hypothesis. And now back to the 5% significance level. So you see that as long as the z-score is in the rejection region, we are going to reject the null hypothesis. Since getting a z-score as extreme as 5 has a probability that it's way less than 5%, we decide to reject the null hypothesis. So that should help you understand what the significance levels are. But that might sound bad, right? Why do we want to reject something that is true? Like, if the null hypothesis is true, don't we just always want to accept it, right? Can we have a significance level of 0%? yes, technically it's possible, but then basically we just cannot reject the null hypothesis anywhere, because under the null hypothesis, as a normal distribution, the z-score can be anywhere from minus infinity to positive infinity. So there is some chances of getting any sort of z-score. And in order to avoid falsely rejecting the null hypothesis, we choose to never reject it, because z-score can be anything. Then doesn't make a very useful test either. And in the earlier example, the probability of getting a z-score of 5, it's very unlikely. So if you don't want to reject the null hypothesis even when the z-score is 5, it's equivalent to being very stubborn, believing that the null hypothesis is true. The risk is that you might be wrong. Well, how could you be wrong? So perhaps as an alternative, maybe the z-score should be distributed in another way. Maybe it's a bell curve that is centered around 5. In that case, it would be much more likely to get a z-score of 5. So now let's come back to this statement. The 5% that we are choosing to reject is the 5% that are far from the center of the distribution. So that's the cases when the evidence is mismatching the null hypothesis, and the 5% probability is the chances we are willing to take when the null hypothesis is true and that we want to reject it even in those situations. And in practice, if you want to be more conservative or more cautious about your experiment, you would lower the alpha value. Let's say if you lower the alpha value to 1%, that means you would only reject the null hypothesis when the z-score is further away from 0, so that the red region below only constitute 1% as the probability under the curve. So in that case, you are more certain that when you make a claim about rejecting the null hypothesis, you are less likely to falsely reject the null hypothesis. Thank you.